Hey everybody, thanks for joining us today. We're going to be talking about digital twins and what's been going on in different events, especially as of June 2021. This will be an evolving topic, but Arvind and I will be diving in. Hope you enjoy it. All right, Arvind, I'm excited to have you on and for us to have this discussion. This will be really good, but talking about the digital twin and how simulation kind of plays into it. So you recently attended the online event for ESI Group. It's called ESI Live, right?
Yes, ESI Live 2020. That was last year.
Okay. All right, good. And you've also written up a post and published that recently about actually some of this topic. So on there, you listened to a presentation by, what was their name again?
Yeah, his name, the gentleman's name is Francisco Cinesta.
So in that, he talked about a few different types of digital twins, right? So the first one he talked about was the virtual twin, right? So tell me a little bit about their view on what that is and what it's used for.
Yeah, I mean, in short, according to Francisco and the ESI group, the virtual twin really refers to a simulation model. So It could be any of their simulations. They have a bunch of them. So anything they can use as a model to represent the real life behavior of the physical asset can be considered as a virtual twin.
Okay. All right, good. Okay, so that's not a crazy concept that a lot of our followers are unfamiliar with. So that's good. So it just needs a little translation over. But then they talked about the digital twin. So let's put that into context. What did he describe as that?
Yeah, in the context of ESI group, the digital twin really is a set of data that comes from the physical asset. So it could be sensor data, for all you know. Most likely it is sensor data. It could be thermal sensors, which are transmitting temperatures. It could be pressure sensors, which could be giving you pressure loads, for example, on a wind turbine blade. So it's a bunch of sensor data that can be collected by this digital twin. So really, the digital twin, in the context of ESI Group's definition, is really a bunch of sensor data that can be used.
Gotcha. Okay, that makes sense. So then, well, let me ask you a clarifying question there. So is that really just from, say, service, or is it also from test as well?
That's a very good question, Chad. It could be both, technically. Service is something where the physical asset has already been deployed, and then it has some sensors, and there's probably some kind of an Internet of Things service that actually gets these values. But on the other hand, during the product development phase, you could as well build a prototype and test this prototype and get the test data as well. So it really does not differentiate whether the source comes from a prototype or the source comes from a live physical asset which is operating in the real world.
Okay. All right, that makes sense. But in both cases, regardless of where you get the data from, we're really not looking at a simulation in this context, right? We're really just talking about a set of data that describes the actual physical behavior of a physical thing, right?
Yes, the digital twin refers to that. Correct.
Okay. All right. So there's this third concept that they described, right, called the hybrid twin, right? Tell us about that.
Yeah. You know, the objective of the virtual twin or the simulation is really to mimic the reality, what really happens to the physical asset, right?
Okay.
The reality, as you know, Chad, is really complex. It cannot be defined by an abstract model. I mean, that's the reality, right? So what happens is the simulations, to some extent, capture the behavior of this physical asset. But it may not be perfect. And in most scenarios, it's not perfect. There is a little bit of, you can call it error, but it's really the inability of the simulation to capture the reality. Now, the digital twin is actually helping helping the virtual twin in bridging this error gap. How?
Okay.
That's the concept of hybrid twin. So it actually gets the real data from the sensors, it compares it with the simulation results, and it actually measures the error. And now it bridges the gap. It learns with more and more data, not enough, but sufficient to make sure that error is minimized. And technically, you can always get it to almost a zero error. And now you have a model which is really what they conceive as a hybrid twin, which is kind of perfect. It mimics the reality.
Interesting. Okay, so there is this concept of capturing sensor data and using it as an input to a simulation. Then you have an independent output. But I guess what you're saying is you're comparing the output of the simulation and the output of the digital twin, the sensor data, to see where the error is, and you're using that to kind of converge?
Yeah, that's the understanding, yes.
Okay. All right. Interesting. So how are they closing that gap? How are they converging it? I mean, are they using AI, machine learning? Are they using some other method? What's the idea there?
I think here I would be speculating because it was not extremely clear, at least during the discourse, what exactly they are using. But I guess it's a combination of these things. They probably have the physical prototype or the physical operating device, but you are limited by the number of sensors you can actually attach into those devices, right?
Sure. Yeah. Absolutely.
So they probably get values at, say, a few different sensor points, but the simulation is a continuum. You could technically place sensors anywhere you want.
Right.
And I guess they probably use some training models to understand how they correlate the real life versus the simulation. And it's possible that they could use some kind of a machine learning kind of algorithm to make sure that this model becomes better.
Right.
But ultimately, the hybrid twin can become a reduced order model, which can, in lightning speed, give you the results that you want. And they talk about that too.
Okay. All right. Well, that's really interesting too. So I think this is something we'll have to follow up with them on to understand exactly how they are closing the gap there, because that would be some really interesting technology. So the other kind of activity that we kind of saw around digital twins is with Siemens Realize Live event, right? So their user event for SimCenter and all of their other solutions out there. So one of the concepts that they talked about there was the executable digital twin. It seems like we're getting all sorts of different types of digital twins nowadays. So let's talk about that. And what's the idea here with the digital twin? Executable digital twin.
As the name suggests, executable digital twin, consider that as a piece of software that can be installed on an edge, or it can be running on an IoT platform. Yeah. All it is a reduced order model of the simulation, along with the ability to get sensor data into this executable software, which has the power to predict.
Okay. Yeah, that makes sense. So it's the idea is that it will mimic and predict the behavior of something, right? But you can almost put it anywhere. Is that kind of the idea?
Yes, that's an interesting point. You can install it onto an edge device because it's a packaged piece of executable. Think of it as an exe file. It's an executable. Yeah. You can install it on an edge device. You can have it in the cloud, obviously. You can also have it in your on-premise server. And ultimately, you can give it to your customers as well so that they can install it and make use of this piece of technology That's lightweight, actually. So it can be installed on a very rudimentary kind of electronic device, and it can perform.
Yeah. I think this is really interesting when you talk about electronics and embedded software that run on products. The one idea here is you can put it on the edge, and the product itself can be on the edge. But there's an interesting side note here in that Mentor has a real-time operating system that it offers out that you can then run on the product. And it'll be really interesting to see if there's some integrations there to see if it performs better or something along those lines. It's more integrated, more out of the box. You don't have to handhold it to kind of prepare it as much. So that will be really interesting to see if they move in that direction as well. There's also this idea, when I heard about this concept, it made me think of custom ICs and FPGAs, right? So on today's products, especially in safety applications, you see ICs fed sensor data, and because, especially in safety applications, they need to be processed so fast, they don't bother with software. It's pure gates on the IC, because that's the fastest way to execute it. And that way you can have it react very, very quickly to automatically brake or swerve to miss something like that. I'm really interested to see eventually if they take the executable digital twin and one day it takes, not the form of software, an executable, but if actually it takes the form of silicon in terms of a custom IC or an FPGA. I mean, that's where you could go with this, right? You basically have a digital twin as a chip that you could then go install, and it's running very, very fast. And when you think about it, running these simulations in real time, that's always been a problem, right? I mean, even reduced order models, people have always been trying to get those to run faster. And I mean, to your knowledge, have people really gotten to the point where you can run it continuously and feed it sensor data and it's always running in real time?
I don't know, but it's really a very interesting future technology that I'm pretty sure we are going to see, because I think the maximum benefits for these digital twins are going to come if they are always vigilant, if they are 100% ready to spot, let's call it a black swan kind of an event that is not really thought through during the design process. And,
Sure.
that's really the power of this. And you are absolutely right, Chad. That's an interesting piece of thought process in terms of future, because what better if the silicon is just made to run that particular model? You can't
Right.
beat that, right? You can't beat that.
Yeah. Yeah, that's about as fast as you're going to get, at least as far as we know today. So, anyway, hey, this has been a really good discussion. I think for everybody out there watching this, I think this is going to be a recurring discussion, right? Because a lot of these solution providers, a lot of manufacturers are continuing to adopt the digital twin in lots of different forms. Simulation has a big role to play in these digital twins. And I think you're going to see more and more versions of digital twins come out over time. So, hey, Arvind, thanks for the discussion. Really good one. And we'll have to do this again real soon.
Thank you, Chad. Yes, it was my pleasure, and I look forward to such future discussions. Thank you.